Hello, everyone. Welcome to Exception Handling Basics. When programs run, unexpected problems can occur. These problems can cause the program to stop working or behave in an unexpected way. To make programs more reliable, Java provides exception handling. Exception handling allows programmers to detect errors and respond to them properly instead of letting the program crash. In this lesson, we will learn about the try block, catch block, multiple catch statements, and the finally block. Let's start with the try block. A try block contains code that may potentially cause an error while the program is running. Java monitors the code inside the try block. If an exception occurs, the program immediately stops executing the remaining statements inside the try block and looks for a matching catch block. In the example shown, the program attempts to divide the number 5 by 0. Since division by 0 is not allowed, an exception will occur during execution. Because this risky code is placed inside a try block, Java can handle the problem more effectively. Next, we have the catch block. A catch block is used to handle exceptions that occur inside the try block. When an exception happens, Java transfers control from the try block to the catch block. The code inside the catch block is then executed. In the example shown, if an exception occurs, the program displays the message "Error handled." Instead of crashing, the program is able to respond to the problem and continue running. Now, let's see how the try and catch blocks work together. First, the program executes the code inside the try block. If no exception occurs, the catch block is skipped. However, if an error occurs, Java immediately stops the execution of the try block and jumps to the catch block. In the example shown, the program attempts to divide 10 by 0, which causes an exception. The catch block then receives the exception object and displays information about the error. This process helps programmers identify and manage problems more efficiently. Sometimes, a program may encounter different types of exceptions. To handle these situations, Java allows the use of multiple catch blocks. Each catch block is designed to handle a specific type of exception. In the example shown, the program tries to store a value in an array position that does not exist. If an arithmetic exception occurs, the program displays the message "math error." If an array index out of bounds exception occurs, the program displays the message "array error." Using multiple catch blocks makes error handling more precise and easier to understand. Another important part of exception handling is the finally block. The code inside a finally block always executes, regardless of whether an exception occurs or not. This makes it useful for tasks that must be completed before the program continues, such as closing files, releasing resources, or displaying completion messages. In the example shown, the message "Done" is displayed every time the program finishes the try-catch process. The finally block helps ensure that important cleanup operations are always performed. To summarize, the try block contains code that may cause an exception, while the catch block handles exceptions when they occur. Multiple catch blocks allow different types of exceptions to be handled separately, and the finally block executes regardless of the outcome. Understanding these basic exception handling tools is essential for creating Java programs that are more reliable, stable, and user-friendly. Thank you for watching, and see you in the next lesson.